The adiabatic process is one in which no heat is gained or lost by a system. It involves a conversion in a system that occurs without input or release of heat from that system. There are all kinds of rapid chemical and physical processes that can be described in this way, and this comes under the field of thermodynamics. So adiabatic literally means impassible. In our introductory course, we're going to talk about adiabatic heating and cooling in relation to air masses, or air parcels. So let me explain how adiabatic heating and cooling happens. Basically, a change in temperature occurs in an air parcel due to a change in pressure in that air mass, while not adding or subtracting any heat. Adiabatic cooling in the atmosphere occurs when an air mass rises, such as in orographic lift, when the parcel runs into a mountain. As the air pressure in the parcel decreases, the molecules are spreading out, so the air expands. As the volume increases, and because there are fewer collisions of molecules, the temperature begins to lower. We say the internal energy has decreased. Adiabatic cooling is cooling by expansion. In the atmosphere, anytime air rises, it cools adiabatically. Adiabatic heating, or warming in the atmosphere, occurs when an air mass or parcel descends after reaching a mountaintop, for instance. The air parcel descends, the pressure on the parcel increases, and as the pressure increases, the parcel's volume decreases, and its temperature increases. It increases its internal energy. Air descending causes the compression of molecules, more collisions, increasing the parcel's temperature, even though no heat is added from an external source. Adiabatic warming is warming by compression. In the atmosphere, anytime air parcels descend, they heat up adiabatically. Now, this is an important process to understand cloud formation and precipitation. So let's look at what's happening on a mountain range as an air parcel moves towards it. On the windward side of a mountain, an air parcel is forced to rise. Its air pressure lowers, it expands and cools adiabatically. It does so at a relatively steady rate of 10 degrees per 1,000 meters, or about 5.5 degrees per 1,000 feet. This is initially called the dry adiabatic rate, meaning unsaturated air. But don't be put off by formulas and crazy terms here. We're looking at the big picture. If a moist parcel rises high enough to reach the dew point temperature, condensation begins and clouds form. This happens at something called the condensation line, or condensation level. We see this often in the clouds in the skies here in Texas, the flat bottom of the clouds where they seem to begin. Now the clouds will produce rain. As the air parcel clears the summit of the mountain, the air is depleted of moisture. The parcel will start to descend on the leeward side. As the parcel descends, the pressure goes up, it compresses, and it warms adiabatically at a relatively steady rate. However, now the temperature is increasing at a slightly different rate, so that the parcel will be warmer than it was on the windward side. The saturated air is becoming unsaturated, and clouds cannot form. This is called the rain shadow effect. You can figure out which way the prevailing winds blow by looking at a satellite picture of a mountain range. The windward side, the side where the wind is blowing into the mountain, is usually green with vegetation. The leeward side is brown with little rain and higher temperatures. This is very pronounced in Hawaii, for instance. The prevailing winds, the moist trade winds, blow from the northeast, hitting the mountain ranges, raining almost every night, leaving them green with dense vegetation. And the leeward side of the mountains are drier, browner, and hotter, all due to adiabatic cooling and warming of air parcels.